All right, guys, we're going to finish up the last of the problems on the egg catcher. So that's just going to be 8, 9, and 10. 8 is if a 1 kilogram ball traveling south at 7 meters per second collides with a 2 kilogram ball traveling in the same direction at 3 meters per second, the velocity of the 2 kilogram ball is increased to 4.5 meters per second in the original direction. What happens to the 1 kilogram ball? So we're going to say that momentum is conserved. And this is the case where they are separate and they stay separate. My second ball I know everything about, so I'm going to get the first one by itself. So I'm going to take, oh, I didn't mean to do that. I'm going to subtract M2 V2 to the other side. So I'm going to have M1 V1 naught plus M2 V2 naught minus M2 V2 is equal to M1 V1. And then I'm going to divide by M1. So I have V1 is M1 V1 naught plus M2 V2 naught minus M2 V2 over M1. So I have 1 kilogram ball traveling at 7 meters per second. I have a 2 kilogram ball traveling at 3 meters per second. Then I have the 2 kilogram ball that is traveling at 4.5 meters per second. And this is all divided by 1. And so I get 4 meters per second in the same direction, south. Hopefully I can spell south right. Okay. If it was negative, then I would have had an answer that was north. Number 9, a mini car of mass 600 kilograms is involved in a head-on collision with a 3,000 kilogram truck traveling at 15 meters per second towards it. The Mini is thrown onto the hood of the truck, don't ask how, which continues at 5 meters per second in the original direction. How fast was the Mini moving? So I'm going to erase this. Another momentum is conserved problem. This one, they are going to have separate momenta to start with, but since it ends up on the hood, they're going to share a momentum together. So that's going to be a totally inelastic collision. And so I want to get the speed of the Mini. So I'm going to subtract M2 V2 to the other side. And divide by M1. Okay, so I'm going to plug in what I know, and this is that I have 600 kilograms plus 3,000 kilograms times 5 minus 3,000 kilograms times 15. And then this is all divided by the mass of the Mini, which is going to be 600 kilograms. And I got 45 meters per second. Geez, I didn't write these problems, but that's right. That's over 90 miles an hour. And then finally, number 10, a proton of mass 1.67 times 10 to the negative 27th kilograms, traveling at 10 to the 7th meters per second, collides with a stationary particle and bounces back at 6 times 10 to the 6 meters per second. If the particle moves forward at 4.0 times 10 to the 6 meters per second, what is its mass? So another conservation of momentum. And so we're going to say that momentum is conserved. And I'm going to say M1 V1 naught plus M2 V2 naught equals M1 V1 plus M2 V2. And we're saying that the other particle is at rest. I want to get its mass. So I'm going to get this by itself. So I'm going to subtract M1 V1 naught and divide by V2. So we have 1.67 times 10 to the negative 27th kilograms times 10 to the 7th minus 1.67. I'm going to run out of space. I'm going to move this over. So I have more room. That'll give us room. All right, so this can be minus 1.67 times 10 to the negative. What's that going to? All right, try it again. Oh, it's moving over a little bit. That's good. All right, so 1.67 times 10 to the negative 27th kilograms times 10 to the 7th minus 1.67 times 10 to the negative 27th kilograms times negative, because we're saying it bounces back, right? 6 times 10 to the 6th meters per second. And I'm going to divide by how fast the other one goes off. And we said that was 4 times 10 to the 6th meters per second. And so the mass of this unknown object is 6.68 times 10 to the negative 27 kilograms. And this leads into our next thing. So we're going to do charge next. So in electricity. So having protons in there is going to be useful.